Now for problem number 3. Is it desired to build a hydroelectric power station across a river having a discharge of 30,000 liters per second at a head of 10 meter, assuming turbine efficiency 80% in speed ratio as 0.83, determine the following. Is it possible to use two turbines with a speed not less than 120 rpm and a specific speed not more than 70 rpm? Letter B. Specify the type of runner that can be used. Also calculate the diameter of runner. Now for the given. The volume flow rate is equal to 30,000 liters per second. The head is 10 meters. The turbine efficiency given is 80%, and the speed ratio is equal to 0.83. Now for the solution. For letter A, it says in the problem a speed not less than 120 rpm, so let's use speed is equal to 120 rpm and specific speed not more than 70 rpm, so we're going to write specific speed not more than 70 rpm. Now let's solve using the formula. Specific speed is equal to the speed times the square root of the brake horsepower all over the head raised to 5 all over 4. The speed is 120 rpm and also head is given, which is 10 meter. The brake horsepower is not given, so we're going to solve for brake horsepower using the formula. Brake power is equal to the specific weight times the volume flow rate times the head times the turbine efficiency given. Now the specific weight is 9.81 kilonewton per cubic meter. The volume flow rate is 30,000 liter per seconds, but we're going to convert it into cubic meters per second, so we're going to multiply 1 cubic meter all over 1000 liter. The head is 10 meters and the turbine efficiency is 0.8. Let's cancel cubic meter in the liter here, Now what is left is kilonewton meter per seconds or kilowatt. We're going to convert it into horsepower, so we're going to multiply 1 HP all over 0.746 kilowatt. Now we're going to cancel kilonewton meter in seconds, and then we're going to cancel kilowatt. Now let's compute for the brake power. 9.81 times 30,000 times 1 all over 1000 liters times 10 times 0.8 times 1 all over 0.746 equals the brake power will now be 3156 horsepower. Now it says in the problem 2 turbines, so we will divide brake power by 2. Now brake power all over turbine, so brake power is 3156 all over the turbine for 2 turbines equals, let's compute, 3156 all over 2 equals, now the brake power all over turbine will now be 1578 horsepower. Now we will now solve for the specific speed. Specific speed is equal to the speed, which is 120 rpm, times the square root of the brake horsepower, which is 1578 all over the head, which is 10 meters, but we're going to compute or we're going to convert meters into feet, so we're going to multiply 3.281 feet, because 1 meter is equal to 3.281 feet raised to 5 all over 4. Now let's now solve for the specific speed. (120) times the square root of 1578 all over 10 times 3.281 raised to 5 all over 4 equals, and the specific speed will now be 60.71 rpm. Now the specific speed is less than 70, so the specific speed is less than 70, so it is possible. Now for letter B, for the type of runner that can be used, we're going to use Francis turbine. Now in solving for the diameter of the runner, the formula will be the speed ratio equals pi times the diameter times the speed all over the square root of 2gh. Now let's substitute for the given. The speed ratio is 0.83 equals pi times the diameter, which is what we're looking for, times the speed, which is 120 rpm, but we're going to divide it by 60 to convert minute into seconds, all over the square root of 2 times the gravity, which is 9.81 meter per second, times the head, which is 10 meters. Now let's compute for the diameter. 0.83 alpha equals shift by alpha x times 120 all over 60 all over the square root of 2 times 9.81 times 10. Shift solve, answer equals. Now the diameter will now be 1.85 meter. This will be the diameter of the runner.